So today I'm going to be showing you how to solve the third FRQ in the 2017 AP Calculus BC FRQs. So let's get started. So this question is going to give you the graph of f prime, which is composed of line segments, which forms a triangle right here and a semicircle right here. So we're going to use that when integrating. Okay, so it says the function f is differentiable on the closed interval -6 to 5, which is pictured here, and satisfies an initial condition of f of -2 equals 7. The graph of f prime, the derivative of f, consists of a semicircle and 3 line segments, as shown in the figure above. So for part A, we want to find the values of f of -6 and f of 5. So if you remember, the way to do this is, if we're given an initial condition, what we can do is actually use an accumulation function to find this value. So how we do that is simply we write out f of -6 equal to our initial y value, which is 7, plus the integral from that initial y value's x coordinate to our new x coordinate. So these are the steps, and eventually we're going to have to take the integral from I flipped it right here because I want to go from -6 to -2. Can't really go from -2 to -6, so that's why I just flipped the sign right here. But if I'm trying to take the integral of this, I don't have the function f prime, so what I'm going to do is just look at the graph, and it's simply going to be area under the curve, which is going to be the area of this triangle right here. So the formula for area of a triangle is 1/2 base times height, so we get the 0.5 times 4, which is the base right here, times the height 2 right here. We're going to do the same thing for the other coordinate, same procedure. This time we don't have to flip the sign because we can take an integral from -2 to 5. So this time it's going to be a little bit more complex. We're going to have a triangle here that's going to represent positive area in the integral, and we're going to have a semicircle that's actually going to have negative area. So here's what it comes out to be if you apply the formulas correctly, and you're going to get f of -6 equals 3, and f of 5 is going to end up being 10 minus 2 pi. Alright, so moving on to part B, it asks on what intervals is f increasing. Justify your answer. So this part requires you to kind of understand the relationship between a derivative and its between the graph of a derivative and the function. So f is increasing when f's slope is positive, right? Or when the derivative is positive. So on what intervals is it increasing? Well, it's increasing on the interval from -6 to 2 and the open interval from 2 to 5, simply because from right here to right here, because its derivative is positive on those intervals from the graph of f prime, which is given right here. So that's how you solve that part, pretty easy. Moving on to part C, find the absolute minimum of f on the closed interval of -6 to 5. Justify your answer. So the method on finding the absolute extrema, so absolute maximum or minimum, is to first consider, you can either do one of two things. You can try all the critical points, which you could figure out from this graph, are when f prime equals 0 or it's undefined, like undefined over here, like its derivative is undefined, or I mean it's undefined, or you can simply look at the relative min and max, and then because if you're looking for absolute min, relative max cannot be an absolute min ever. So that's how you can narrow down your choices, and then you also have to plug in the endpoints to check for absolute minimum value. So the way this part is designed is that it's going to use the answers from part A, because we're going to be checking these endpoints of x equals -6 and x equals 5. So first we have to find any of the relative mins that we also have to test. So a relative minimum is when f prime changes from negative to positive. So we can draw a number line right here, and notice that at x equals 2, f prime is going from negative values to positive values, which means there must be a relative minimum here, which could potentially also be the absolute minimum. So what we're going to do is plug in all of these in the original function and find it. So f of 2 we don't have, but we can also just do what we did in part A for f of 2. So here are the steps, and f of 2 is actually going to be the relative minimum with a value of 7 minus 2 pi. I mean the absolute minimum. It's also a relative minimum. So this ends up being the right answer for this part, because this value is lower than these others, and these were the only possible candidates. Alright, moving on to the last part, it says for each of f double prime of -5 and f double prime of 3, find the value or explain if it doesn't exist, or explain why it doesn't exist. So for f double prime of -5, well, it's going to exist because f double prime of -5 is simply the slope at f prime of -5. So f prime of -5 is right over here, so the slope over here is, remember, rise over run, so rise 2, run 4, it's going to be negative because it's going there, so it's going to be equal to negative 0.5 or 1/2. Now f double prime of 3 on the other hand is not going to exist because there's something called a sharp turn at x equals 3 on the graph of f prime, which means that it's not differentiable at that x value, so it's definitely not going to exist. Alright, so that's it for this question. If you have any questions about this question or other questions in AP Calc, then be sure to leave it in the comments below, and I hope this helped. Thanks for watching.